Hi guys, welcome to this video on the surface area of a pyramid. Now remember from last year we've got the surface area definition, which is the area of all the faces on the outside of a solid, and then we add them together, so it's the sum of all the areas on the faces of that particular solid. In this case we're going to have a look at a pyramid. Now remember that it's probably best to draw the net of the solid because it's easier to see what happens when it looks like in a two-dimensional shape. So can you remember what the net of a pyramid would look like? So just visualize what a pyramid is. Okay, so there's one particular type of pyramid. Here we've got a rectangular base pyramid. And what would it look like if we saw its net? So think about that for a second. And it would probably look something like this. So we've got the base on the bottom. That base is this base on the bottom. And then we've got 1, 2, 3, 4 different triangles. Now if that base was a square, it would have 4 congruent or identical triangles. But in this case we've got a rectangular base. So that rectangular base means that this triangle and this triangle are the same, and that triangle and that triangle are the same. So we can do a bit of simplification when we work out the areas. Okay, our first example is calculate the surface area of a square-based pyramid. So the base of the pyramid is a square, and we've got 15 by 15. And the slant height, which is the height of this triangle, which will be the same as all the triangles because it's a square-based pyramid, is 20. So looking at the net, putting in dimensions, so the base is 15 by 15, and each triangle has a perpendicular height of 20, which means we've got the base is 15 and the perpendicular height is 20. So the surface area is, 15 times 15, or 15 squared. That calculates the area of that square. And then we got 4 congruent triangles. We got 4 lots of a half times base times height. Calculating that, end up getting 825 square units. So I think the easiest way is to draw the net and then individually look at what shapes you have. Okay, going a little bit further and looking at a rectangular based pyramid. Now in this question we've got 12 centimeters by 16 centimeters, which is the rectangular base, and we've got from the apex, the top of the pyramid, down to the base, the center of the base, we end up having the perpendicular height, and that perpendicular height is 15 centimeters. Okay, if we have a look at this type of pyramid, we've got 1, 2 congruent triangles, another 2 congruent triangles, and the rectangular base. Now to work out the slant height of the 2 different triangles, we've got this slant height and also this slant height. So the slant height will be from the top of the pyramid going down to that face, to the bottom of that triangle, and the other slant height is from the top of the pyramid all the way down on that particular face of the triangle. And how might we be able to work those specific lengths out given the measurements that we have? Okay, if you said Pythagoras, you're on the right track. Excellent. So we end up having these measurements. We've got 15 centimeters being from the top down to the bottom. And then we have 6 centimeters, which is a half of 8. So this measurement here is half of 16, because 16 is the whole way across the rectangle, but we want half of that, which is 8 centimeters. So sorry, that's 8 centimeters. This one is 6 centimeters. So that's 6 centimeters, a half of 12. And that's the top to the bottom, which is 15. So in this case, that's y. We've labeled it y. Using Pythagoras' theorem, it doesn't work out to be a nice whole integer, so we end up leaving our answer as a third. Then looking at this right angled triangle, use Pythagoras again. So then a half of 16 is 8, then we got 15, and then using Pythagoras theorem, we end up getting an integer answer, which is 17. Okay, so now looking at this and this height, we've got the square root of 261. And looking at this height and this height, we've got 17. So y is this, and x, which I've just introduced, is this and this. Okay, so the surface area of this pyramid is going to be the area of that base, which is 12 by 16. 12 by 16, that's the base of the pyramid. Then we have 2 times the area of that triangle, which is a half times base times perpendicular height. And over here, that calculation is a half times base times perpendicular height, then multiply that by 2. Now, this line here is just saying, okay, that base is 192. This works out to be 204. And then this, leaving our answer in a third, is 6 root 261. We want the specific measurement in 2 decimal places. So here is our answer rounded off to 2 decimal places. So just to recap on that question, that pyramid didn't have the perpendicular heights on the triangular faces. So we worked those out in order to work out our area of the triangles, and that was done through 2 lots of Pythagoras. Okay, have a go at these 2. Pause the video, answer these 2, and then I'll put the answers up in a moment and just check and verify if you've got the correct answer and you're on the right track. Okay, here are the solutions, all the answers. Let me know if you have any issues. Okay, thanks for watching, guys.